Hello everyone, here I am going to give a brief demo on DBLOC, the web application we designed to provide a density-based clustering service over location-based services. The goal here is to help the users find out the density-based clusters on location-based services like Zillow, Google Maps, Flickr, etc. Our algorithm HDBScan finds out the optimum cluster assignment function and thus is able to assign each tuple to its respective clusters. Before moving forward, let me give you an example of Zillow. So once you go to Zillow and try to look for a house, you enter the price, the square feet and other criteria to filter the houses. And once you select an area in which you want to look for a house, Zillow returns the respective tuples. There is no way you can find out what is the distribution of these houses in the selected area, what is the price and the size distribution of the clusters in the selected area. These questions help the user look for houses in the area of his or her liking. Our system DBLOC helps us answer these questions just by querying the backend interface. The backend interface of location-based services is usually a k-nearest neighbor interface. Our algorithm helps us to find the clusters by smartly querying the KNN interface and not by crawling all of the tuples in the location-based services. Before we get started, let me explain the user interface. So the user interface predominantly consists of 4 panels. One is the cluster parameters panel, where you give the different DBScan parameters to cluster on. Second, the cluster merging parameters panel, where you give the different merge criteria to merge 2 close clusters with each other. Number 3 is the cluster analytics panel, where once n number of clusters are discovered, you would just want to output the top k clusters based on different attributes like price or square feet and on different aggregation functions like average or median. And 4 is the cluster area selection panel, where you select the area on which you want to do the clustering on. Let us get started. So as in Zillow, we choose an area from the input map on which we want to perform the clustering on. Once you click select area, a new rectangle pops up which you can resize and choose a given area. We have also pre-populated boundary boxes for popular cities. So just click the search button and enter the name of a popular city to set the boundary. Here, let me go ahead and give Dallas. So once Dallas is selected, you can see that the boundary box covers all of the boundaries of Dallas. And then you click set boundary. Let us now choose the cluster parameters. Here you can see you can choose different data sets to cluster on. One is the Zillow dataset and the other is the Google Maps dataset. And you also have different POIs. For Zillow, we offer houses for sale right now. Then you have the epsilon and the min points parameters. The epsilon defines the size of the grid, like in DBScan, on which you want to do the clustering. And minimum points tells you whether a cluster is dense or not. So if the minimum points is 25, if a grid, epsilon grid, has lesser than 25 points, then it is not dense, and if it has more than 25 points, it is dense. And finally, you have the query budget. So if you just want to spend only 500 queries on the backend LBS service, we have pre-populated some examples with the right epsilon and min points and the right area to give you the optimum experience of DBLOC. So let me go ahead and select one of these examples. So this example clusters Dallas downtown area and the suburban areas around it. And we found the optimum epsilon parameters and min points parameters, and we have keyed them in. So now let me go ahead and start clustering. Once you give start clustering, the UI sends the request to the backend server, and the backend server processes it. You can see this on the status bar up top. The system outputs the 1D clusters as and when it finds it. Here you can see different smaller clusters coming up on the map. Let us now wait till the 1D clustering phase is over. Once all of these 1D clusters are found, it's time to merge them into bigger meaningful clusters which make sense to the human eye. So we use the merging parameters panel to accomplish this. There are different merging methods such as L distance pairs or cluster center, and parameters for these different merging methods are below them. To know more about these merging techniques, please refer to the demo paper that is being published at SIGMOD. Here we want to choose L distance pairs, and we want to set any cluster that's going to be outputted by this merging parameters to be minimum of 15 points. The closest pair of points signifies that the merging method is actually going to take 10 closest pair of points between two clusters and see if they fall within a certain threshold, and if they do, it's going to merge them. So let me go ahead and give merge. So once it is merged, you can see the different clusters on the map with different color coding. Now it's time to do some analytics on these clusters and find out what are the different distributions. Let us go ahead and do some cluster analytics on these clusters. So let us select the top 10 clusters to display, and let us also select a ranking attribute to rank on. So let us go with square feet for now. The aggregate function that I'm choosing is average, and I'm going to order by the max. So I'm going to get top 10 clusters in this area with the maximum square feet. Let me go ahead and give rank. Here you can see that clusters, top 10 clusters by square feet are being outputted. So once you go down, you can see what is the square feet and what is the average square feet and what is the average price per each cluster, and you can see that the red cluster dominates all of the other clusters in the area. And you can also see that the downtown clusters, though not very great in square feet, are too costly. That's because they're in the downtown. So by this, our users are better suited to go and look for houses only in those areas which is of interest to them. We also have a cluster comparison panel which allows us to compare these different clusters. So here if you see, all of these clusters are shown by the different colors on the map and are shown by the ratios with the largest cluster in that particular attribute. This can be a useful tool while comparing different clusters. To conclude, using DBLOC, we can get to know interesting data and point of interest distributions on location-based services, which can be never possible over a traditional KN interface. Thank you for watching.